Hi, Tony here. Welcome to my channel. Coming to you from beautiful Sydney, Australia. And if you have chosen to have a look at this video, it's probably because you're thinking of either buying or you already have bought a Mercury Optimax engine for your boat. And so I wanted to talk to you a bit about these engines. They get a bit of bad press, which is a bit undeserved in my opinion. This is my baby here. It's a 135 horsepower Optimax V6, 2.5 litres. It was built in July 2007. I bought the engine when it was around about 10 years old, and I've owned it for the past 7 years, and it's been nothing but pure joy for me. It's been fantastic. As you may or may not know, Optimaxes are incredibly powerful. They've got a fantastic mid-range and upper, and they're incredibly economical on fuel. They use less than half the fuel of a traditional two-stroke, and apart from the fact that they're a bit noisy between 3,000 and 3,500 RPM, and they need some special care in some areas, they are a fantastic motor. And early on they did have some issues, but I think Mercury worked through those issues in the first few years, and probably from about 2002, 2003 onwards, they're a fantastic engine. So my talk's going to be in like 3 bits. My first talk is going to be about the history of the Optimaxes, and it's an interesting history. My second talk is going to be about 15 tips that I've learned over the years that will help your ownership of the Optimax be a lot more enjoyable, and they're easy tips to follow, thick tips that you can do. And then last part, I will actually start this baby up and run it on the trailer here, and you can sort of hear how it sounds. I will then grab the camera and I will take you to some of the detailed spots on the engine and show you in detail some of the bits and pieces that I was talking about. So firstly, a history. The history of the Optimax actually has an Australian connection, believe it or not. It first got conceived as an invention by an Australian engineer, Ralph Sarich, based in Perth, and he invented a new orbital engine, which never quite got off the ground. They had problems with the seals and stuff, but as part of the design of the orbital engine, he developed a new fuel injector, which was far and above anything else available at the time. That was back in 1972. Ralph's actually in his 80s now, and he sold his technology to various companies, and he's a billionaire. He's done really well for himself. So back in the 90s, Ralph sold his injector technology to both Mercury and Evinrude. Evinrude decided to go with a slightly different technology based out of Europe, and they created the Fight engines in the 90s. And unfortunately, we all know what happened to Fight. They never really became reliable or succeeded commercially. Whereas Mercury, because of some pressure from the environmental agencies in the States, there's a lot of engines that run on lakes and stuff in the States. there was a lot of pressure for them to improve their emissions technology back in the late 80s and early 90s. And for those of you who aren't familiar with two-stroke outboard technology, what you might not know is that the traditional two-stroke outboard actually runs on a 50-to-1 fuel oil premix, and you actually mix it up as you put it in the when it goes into the fuel tank, and then the engine sucks it up through the carburetors, and it goes through goes through the sump of the engine first, where the oil component keeps the sump components lubricated, and then through various ports and into the engine, and gets ignited and then goes out via another port. But because it's using ports and it goes sort of sideways past the piston and then back into the top of the cylinder, and then out again via another port, it has to rely on the upward stroke of the piston to get rid of the expent gas. And up to a third of the fuel oil mix that goes into a traditional two-stroke actually gets exhausted and through back into the lake. And if you can imagine the amount of two-stroke oil that was going into all those American lakes, it was just amazing. So the environmentalists said to Mercury, look, and all the outboard manufacturers, you can't do this anymore. And hence Mercury started looking at alternative technologies. And even before the four-strokes came along, and the four-strokes did come along, they invented this new direct fuel injected technology with the Optimax. And how the Optimax works is it has a little air compressor bolted onto the top of the engine, which is run off the alternator belt, which injects air into the cylinders at around about 90 pounds per square inch. And there's actually another set of injectors on the fuel rail which injects a very fine mist of fuel, just fuel, no oil, into the cylinder, a very fine narrow mist at slightly less, about 80 psi, and it's got very precise control using the computer on the engine, and so it's able to achieve almost a complete burn compared to the very inefficient burn of the old traditional two-strokes. So that's how it sort of achieves its efficiency. And I hear you ask, well, then how does the Optimax achieve lubrication on all the lower parts of the engine, the conrods and the crankshaft and the bearings and all that? And how it does that, it's got a separate oil pump, which again is controlled off the computer on the engine, and it's got a little sort of pulsing solenoid, and the computer just speeds up and slows down the solenoid according to demand. And it's got a whole bunch of separate little pipes coming off the oil pump, directing oil flow into different parts of the engine, so it can pick up the sump and the crankshaft bearings, conrods, all that. And the computer's very smart, and it actually varies the ratio of oil to fuel mix in the engine from about I think 44 to 1 at top end speed, flat out, down to about 400 to 1 at idle. So obviously it uses a lot less oil than a traditional two-stroke, which is great, because the Optimax oil is not inexpensive, and I'll sort of get to that. Just have a quick look at my notes and see if there's anything else I wanted to tell you about history that I've forgotten. Bear with me for a second. Oh yes, the V6 Optimaxes, which of mine is one, are based on the original Mercury traditional V6, which was the Black Max, which came out in 1976. And this particular block has a fantastic reputation. It's been used for Mercury racing, and it's been available in carby form or traditional fuel injection form, not direct injection, for quite a number of years, and it's got a fantastic reputation. It's one of the best blocks that Mercury have ever built, and the first Optimax was a 200 horse, I think, in 1997. I think that was probably a 3-litre block, and then it was extended to both higher horsepower and lower horsepower, from up to 300, I think, down to 75 blocks during its life, and production continued until 2018. So 21 years of production, which is a pretty good lifetime for any engine. So there are plenty of them around, and many of them have done excellent service. Again, I'll just check my notes. Oh yes, when the Optimaxes first came out, there were a lot of early troubles. Things like broken alternator bolts, broken air compressor bolts, pistons sticking in cylinders, causing massive failures. And it took them quite a few years to sort all this stuff out. And so in 2001, they actually suspended production of the Optimaxes for a time, so they could sort all these problems out. But they did that. And so what it means is that if you can get an Optimax that's probably about 2002, 2003 onwards, then you're going to have a very good engine. There's have still been the odd issues, I think, mainly from the vendors that they got to supply their components. There were some issues with the air compressors in, I think, 2007, and then again around about 2014, and there were various recalls done on those engines, and there was also some issues with coils. I think again around 2000 and yeah, the coil issue was between 2007 and I think 2008. Mainly just the air compressors and the coils, but other than that, they've been great. They've been great. So you bought an Optimax, and or you're thinking about buying it, or you bought it. What are the 15 tips that I want to give you on these engines? Tip number 1. When you first start the engine up, you've launched it from the ramp, and don't give it the full grunt for a little while. Let it warm up a bit first. I would suggest keeping it below around 1500 RPM for, say, the first 5 to 10 minutes. And the reason is the tolerances in these engines are very tight. And if you give it full power early on, the moving bits like the pistons and rings and that start to expand, and the rest of the block hasn't warmed up sufficiently yet, you can actually get a situation where the piston can actually lock in the cylinder and break a rod. We'll put a rod through the side of the block, so massive failure. So always just run it at fast idle, say up to 1500 for that first 5 to 10 minutes till you start to see the temperature gauge start to move a bit, and then you find you can run it hard all day. Only use the Merc Optimax DFI oil on these engines. Don't be tempted to cheap out on the oil. So this is the Mercury DFI oil. It's expensive, but your engine won't use a lot of it, and it's not just a recommendation, it's a must. Only use this oil, because as you can imagine, there's not a lot of it being used, and it's going to key spots on the engine, and other oils just won't measure up. You've got to use the proper Optimax DFI oil, and if you buy it in bulk, this was a 9.5 litre container. You can probably get it for not too bad price. I think in Australia I can get one of those containers brand new for about 190 Australian, and maybe if I saw some second hand I might be able to get it a bit cheaper than that. But I bought that container when I first bought the engine. There was a bit of oil in the boat tank as well, so I'm about halfway through it. I don't use the engine a lot, but the oil won't cost you a fortune, because although it's expensive, the initial purchase, you won't use much. So that was my number 2. Number 3, don't over prop your engine. What I mean by that, every time the prop spins 1 revolution, it travels a certain distance. Now this is an 18-foot boat, medium-sized bow rider, and on this boat I have a 19-inch stainless steel prop, and what that means is that every time that propeller rotates through 1 revolution, the prop will travel forward by 19 inches. And I wouldn't recommend any higher pitch prop for this boat than that. That's a perfect pitch. With that prop, I can pull an adult skier on one skier out deep water with 7 people on the boat, and it'll just pop them straight out. That's a great prop. And if you've got a bigger boat with a similar size engine, say a 21 footer or even a bit bigger, then think about using a smaller pitch prop, a 17-inch, or maybe, for the larger boat, even a 15-inch. And if your boat's smaller than that, than mine, 18 foot, I'll tell you the truth, I wouldn't go much beyond 19 inches. And all it means is when you're going at high revs, you'll just have to watch out that you don't over rev your engine. So yeah, less is more as far as propping these engines go. To keep them up in their power band and keep them revving free, they hate bogging down and running up under load at low revs. Don't do that. Don't over prop your engine. So that was number 3. Number 4, the water pump in these engines is marginal. How they work, they've got like a little rubber impeller that spins around, and the impeller is down here in your lower unit, and because these impellers are fairly marginal, I've got some here I'll show you. Here is a brand new impeller. Sorry, it's in the plastic bag, a bit hard to see. See, that's what it looks like. And can you see that the vanes are quite straight, they're sticking straight up. Now after some service, after they've been operating for some time, these impellers start to get a set. And what I mean by that, because they're confined inside the water pump, they start to have a bit of a slope on the impellers. And can you see that on the vanes there, that they've got that slope? And I've got another one here, which has got probably got even more of a slope on it. And both of those two with the slope, I think they were both in service for around 3 years each. What I'd recommend is probably 3 years is the absolute maximum between the impeller change. I'd probably say 2 years is the optimum if you use your boat a lot, maybe even more frequent, but 2 years is probably the sweet spot. for an impeller change. And impeller change is not particularly hard if you're good with tools. It's something you could do yourself. It's something I do. And there are a lot of videos online about impeller changes, so I'm not going to bore you with all the details of it, but what I will tell you is just a couple of things to be aware of if you decide to do it yourself. And it's not hard. You want to be a nice strong person though, because these lower units are quite heavy. The lower unit itself is about 29 kilos, and then the prop is about another 10 kilos on top of that. So what you would normally do is take your prop off first, just make it a bit easier when you're manoeuvring the lower unit around, and then take the lower unit. But the two things on the impeller change I wanted to tell you about that weren't on the videos that I saw and that might help you a bit is firstly the speedometer pickup. There's a flexible tube towards the front of the lower unit on these engines, which is just a little tiny rubber tube, and it plugs into a fitting on the lower unit. And when you first separate the lower unit from the engine, you'll find that it'll try and pull the speedo tube down, and what you've got to do is just stick your finger on that little fitting inside the lower unit where the speedo tube goes in, and as you push it down, it'll release. Don't try and just pull the speedo tube out of that fitting just with brute force, because you'll ruin the seal. You've actually got to press down on the fitting and then it automatically releases. So that's the first little trick. The second little trick is that when you separate the lower unit, there's a copper pipe inside the midsection of the engine, which actually connects the output of the water pump to the block. And quite often when you separate the lower unit, you'll find that copper pipe comes down and actually comes out with the lower unit, which is fine. And so when you get that all separated out, you can just put the copper pipe to the side. But then when you're replacing it, don't just mount the copper pipe on the top of the water pump and hope that it all just lines up, because it's quite finicky getting that copper pipe back into the bottom of the block. There's quite a narrow little opening, and you've got to aim it well to make sure that it runs home to the correct spot on the block. And if you don't, then the water just spews out the copper pipe and comes back down, and you'll get no cooling into your engine, which obviously you don't want. And the way you all know that is because when you've put the lower unit back on, and I'm speaking from experience here, and you start the engine up, your impeller's fine because it's got plenty of water because you're running it on the earmuffs, but no water going up into the engine, and so your little telltale water that comes out of the bottom of the back of the engine, there won't be any telltale, so you'll know. But what I do is I actually aim the copper pipe up into the bottom of the block and make sure it's home first, and then I just hold it in position with a finger, and then make the lower unit connection on the water pump to the copper pipe as I put it all back together, which is a bit fiddly, but you can do it. And what I do is I actually have I tilt the engine up about halfway up, and I have like a little stool where the lower unit rests on the stool, so I'm not sort of just holding it with my back strain all that time, and then you can just play around with it until you get everything lined up. Actually, there is one other thing I wanted to tell you about impeller changes that I learnt, and that is when you before you take the lower unit off, you've got to make sure the engine is in forward gear, because it's going to make life a lot easier for you when you're trying to match the splines when you're putting it back together. When you put it into forward gear, you then turn the engine off, and then you can start pulling things apart, but don't have that throttle lever too far forward, because what will happen is once you separate the lower unit, the gear selector on the lower unit will just flick back a little bit, still in forward, but it flicks back a little bit and misalign the splines. And then what you'll find is when you put it all back together, your gear selection on your front controls will be slightly out of whack with your gears in the engine. And as you bring it back into neutral after you've had it running into forward, and it'll actually try and select reverse, and you'll get a crunch. So bottom line, when you're first putting it into forward and then turning it off, just in forward, not too far in forward, not with any kind of throttle on it, just in forward is enough. You hear it sort of clunk into gear in forward, no more than that, and that way you'll have a much better time doing your impeller, and good luck with that. Okay, number 5. If you don't use the boat a lot, particularly over winter, it's a very good idea to run it at least once every month, 4 weeks, on the earmuffs, on the trailer, just to get everything flowing, get oil flowing through all the injectors, get fuel flowing, get everything running. And believe me, it'll be the best thing you ever did, and it'll mean less drama for you than compared to leaving it for 6 months and hauling it out of the garage and then hoping it all starts. So do that. Run it on the trailer at least once a month. You don't have to rev it up or anything, just, say up to that 1000 RPM, 1200 or whatever. Just cycle it through the gears, make sure everything works, let it run for 10 minutes or so, and believe me, it'll be the best thing you ever did. And I also highly recommend when you do that, don't use the hose attachment on the back of the engine, use the muffs. And the reason I say that is because if you use the hose attachment on the engine, it still kills the engine, which is fine, but it actually forces water back down the copper pipe to the top of the water pump. And then of course the water pump is being spun by the shaft and sort of trying to send the water back up against that pressure. But what tends to happen is all the water stays at the top of the vanes. And what you can see it on this one a little bit, and I don't know how well you can see it. This one, I used that method of the hose connection on the back of the engine. I don't know if you can see that, but can you see that the bottom of the vanes are slightly swollen compared to the top, and they're all the same. And what's happened, I think, is that when it's been run on the trailer, the water's been fine at the top of the impeller, but the impeller's forced all the water up to the top of the engine, and so the bottom part of these vanes hasn't had the same cooling, and so they've started to expand and swell. And so for that reason, I would say use the earmuffs. Don't use the hose connection on the engine. It's only a small thing, but it just helps your impeller last longer, and I really recommend that. Fuel. This is number 6, by the way, so we're getting through them. Fuel. Now, fuel is very important on these engines. I'd say 80-90% of the problems that they have on these engines is due to fuel problems. First golden rule with these engines is no ethanol. No ethanol whatsoever. Resist. I know it's a bit cheaper at the Bowser, but resist that temptation. You'll see the E10 ethanol, and don't buy it. Only use pure unleaded for these engines. And 91 octane is fine. You don't need 95 or 98 or whatever. 91's fine, but you stick with the pure unleaded. Do not use ethanol. The ethanol will deteriorate as it sits in the tank. It'll corrode all the rubber bits of your fuel system, your hoses and joins and stuff like that. And likewise, the bits and pieces inside the engine. Ethanol is actually hygroscopic. That means it absorbs water. So the longer it sits around, and if you've got a 70 litre tank and you're running E10, that means you can have up to 7 litres of ethanol in your tank. And can you imagine all the water that's going to absorb? So don't use ethanol. And if for whatever reason a bit of water does get into your system, because the fuel system on these is open, it's got a breather built into the filler, and so water vapour and that can get in, particularly if your boat's sitting out in the weather like mine. Even though I have a cover on it, water can still get in. So I actually run 2 water filters on my boat, and I'll show you later where they are. Now the first one is just one you can buy off the shelf. This is an Easterner one. They're about $15, and what they are is like a big screw-on filter, a bit like the oil filter on your car. And so it sits with the gasket side up. Photo of it, and so as time goes on, the water just collects in the bottom, and then basically you just unscrew this filter and just chuck whatever's in the filter once a year, and just buy a new filter and replace it. And if you've got some fresh fuel in a container or whatever, my tip is to actually just fill this up before you put it back on. And that way you won't have to spend half an hour squeezing the bulb trying to pump the fuel through. So do that. Now on the Optimaxes, not only do we have the option of the boat mounted fuel filter, which I highly recommend, but there's actually a fuel filter on the engine itself, and later on I'll show you where that is. And here's the one that was originally on the engine when I got it. And so it's a bit like the one I just showed you, a bit smaller, but it does the same job. And you can see here it's got a water sensor on the bottom which plugs into the computer on the engine. And the idea is if the water sensor sees any water, then obviously water's conductive, and the outside of this filter is grounded, and so you'll get a current from the sensor to the ground, and the computer will know and give you a beep. And I've never had that situation, but it may even, throttle back the motor or turn it off, I don't know. But at least you'll get a warning alarm. Now when you buy these, the sensor actually comes loose, and you'll actually have to plug it into the bottom of the filter. And don't just use plumber's tape or whatever, PTFE. With fuel it just won't work. The fuel will just leak straight past it with any sort of pressure on it. So I actually used, when I replaced this one, I actually used some thread locker, and this is red thread locker, which I think it requires high temperature to release, and I think there's also blue thread locker you can get, which doesn't require high temperature, but you'll need some sort of sealant to seal that sensor, and yeah, thread locker's probably the way to go. And what you do is, of course, once you put this back on the engine, you then squeeze your bulb until there's plenty of pressure there, and then just visually check for any leakage around the bottom of the filter. With the engine mounted fuel filters, I don't replace them as a rule every year. I just usually take them off the engine and just check it, see if there's any water in the bottom, and check for any rust or whatever inside the filter. And if it looks good and there's no water in it, then I'll just pop it straight back on, because they're a bit more expensive than your generic fuel filters, your boat mounted fuel filters. I think these, even the non-OEM filters will cost, which you can get, by the way. You don't have to buy the Mercury one. This is the one I replaced it with, was the Sierra, and they're about 30 or 40 bucks, I think. And again, I'm talking Australian dollars. So yeah, just take it to bits and just check that it's fine, but you don't have to replace the engine mounted fuel filter every year. that actually, what I've just talked to you about, that covered points 6 and 7. And 8, I've already talked about. That was about flushing the engine. But actually 8, there is a little bit more to talk about on 8. So I talked about running it on the earmuffs monthly. The other thing, and I shouldn't even have to tell you this, is after every use, even in fresh water, even if you're running in lakes, flush your engine with clean, fresh water for at least 5 minutes after every use, and that way you'll clean all the salt water out of the engine, and you won't get salt water building up in all the passages. And if you've been running in lakes, rivers or whatever, you never know, you might have picked up a bit of sand or mud or whatever, and just giving it that flush after every use will flush all that stuff out. So can't emphasize that enough. You must flush your engine with fresh clean water after every use. Nine, gearbox oil. Now, again, this is something that you can probably do. You don't need to get a mechanic to do this. The seals on these gearboxes are pretty good. But if you can imagine, running along at 30 miles an hour or whatever speed you go, there's a lot of water pressure on that lower unit, a lot of water pressure on the seals. And so, a little bit of water will get through. So once a year, without fail, change your lower unit gearbox oil. And with the Optimaxes, you must use the OEM oil. And for 75 horsepower and above, and I think all the Optimaxes are that, you must use the high performance gear lube. And this is the OEM high performance gear lube. It's SAE 90. It's designed for the purpose, and it will actually still protect your engine even when there is a component of water in the oil. So I highly recommend that you use the OEM oil. They come in a 946 ml container, and I think on this engine it probably uses 600 or 700 mils for a change. There might be a bit of leakage or whatever, but one container should happily get you through a change. And I think the last one I bought was about $20 Australian, so they're not too expensive. And when you do change the oil, highly recommend one of these gear lube pumps. This is the OEM version, and what it is, the top of the middle of the pump here, that screw, the screws onto the oil container, and the yellow bit screws onto the bottom of your lower unit, and then you just push this up and down here and it just pumps. And the way it works is you drain all the oil out first. There's a top and a bottom plug. Release all the oil, and then when it's all dripped out, you connect the pump to the bottom plug, screw it in, so it's nice and snug, not too tight, or you'll strip the plastic threads on the fitting. Don't over tighten it, and then just pump it up until it starts to ooze out the top plug. And of course, don't do it when the engine's in this position. You've got to tilt it down so that the fins on the cavitation plate on the lower unit is horizontal, so it's right down to its lower position and level, and that way you'll get an accurate oil level reading, so that you'll know when you probably filled it up. If you were to try and do it in this position, of course, because the upper plug is lower down because the engine's sloping, you wouldn't be able to get enough oil into the gearbox. So make sure you tilt it down so that the engine cavitation is horizontal. And I even have a little spirit level, and I make sure it's absolutely flat before I do my oil change. So do that. Making sure I don't leave any of these points out. Ah yes, next one. You have to grease all the grease points on the engine. That's very important because those pivots on the engine that steer the engine, and also the pivot that up and down that tilts the engine, they're all grease filled, and you've got to make sure that they're well greased because there's a lot of pressure on those. And there are other grease points on their engine. There's one up inside the engine for the pulleys on the belt, and various other spots, and I think there are plenty of videos that can tell you where that is. Now, this is the grease gun that I use, and my grease gun actually has two options. It's got a flexible connection here, and it's got a non-flexible one. You just screw one off and screw the other one on. And so for the bulk of all the grease points, I use the non-flexible one because it means you can get lots of pressure and get it onto the nipple, and then quite often these things lock quite hard onto the grease nipple, and you try and pull it off and you're worried you're going to break your connection, break your hose. Whereas with this you can give it a good hard yank and get it off. So use this one for all of them. The only one where you're going to need the flexible one is on the very front of the engine, just underneath the steering connection, because it's a bit fiddly to get to and you won't be able to get a rigid one into it. So you will still need this, but just for that one on the front of the engine where the steering controls are. So I would say grease up every year if you've got time, or 2 years is probably okay. Next one, batteries. Now, these engines are very high demand on batteries. They use the battery to run the starter crank, of course, all the electronics, and the crank has also got to run the air compressor and compress up to 90 psi. It's also got a number of fuel pumps, one of which is electric. So there's a lot of electrical demand on these engines. And for that reason, you've got to use at least 800 amps cold cranking capacity battery, marine type. Don't be tempted to cheap out on batteries for these engines. Minimum 800 amps cold cranking, which is, I think, equates to 1000 amps marine cranking, and the only difference between cold cranking and marine cranking is the temperature at which they do it. I think cold cranking's at 0 degrees Fahrenheit and marine cranking's at 32 degrees Fahrenheit, but most battery manufacturers specify cold cranking. I run a 830 amp cold cranking battery on this boat, and it's been great. So very important to use a good strong battery if you want to have reliable operation. Next one, and this is a bit of a trick too. On the front controls, and I'll show you this later, there's actually a little lanyard, a little cord which you can attach to your belt, and it plugs into the control unit on the front. And occasionally that lanyard might pull out, and what's happened, I believe, is that some people have pulled the lanyard out and forgotten to put it back in when they wanted to restart the engine, and so they've tried to restart the engine and crank, and suddenly realised, oh, I forgot the lanyard. So they put the lanyard back in and tried it again, and lo and behold, the engine still won't start. And the reason is that there was a component, and I'm not sure, I think they have strengthened it, but there was a component in the computer which, when the lanyard was pulled out and you cranked the engine, caused that component to fail. And so you had to take it back to a repairer and get that computer repaired or replaced, which is a lot of money. So always make sure that that lanyard, even if it's not on your belt, that it's hooked up to the controls at the front to avoid that happening to you, because it wouldn't be nice. Next one, there is a little strainer. What happens on the air compressors to these things, it's actually cooled with the same water that's used to cool the engine, and it runs through a little strainer. And if that strainer gets clogged up with mud or crap, then the water supply to the compressor gets cut off. And you'll know this, because the reason you'll know it is because the telltale water that comes at the back of the engine actually is the water that's come through the compressor. So if your telltale's weak or stopped, then you'll know that that strainer is blocked and you'll have to clean it. And I believe it's quite hard to get to, so that might be one you'll have to leave for a mechanic to do. I haven't done it, but happily my telltale is still pretty good. Spark plugs. Now, you may or may not be aware that these engines use iridium type spark plugs, which are a special long life plug, and they're used quite a lot in cars now as well. And they've got a special iridium tip on them, which is very resistant to corrosion at high temperatures or, during spark operations. And in a car, those type of plugs will last up to, I think, 160,000 kilometres. They last a long time. And if you look at the standard OEM instructions for these engines, and they'll talk about, replacing the plugs at 100 hours or 200 hours or whatever. And no problem if you want to pull a plug out and have a look, make sure it's nice and clean or whatever, not fouled. But if your engine's running great, I wouldn't be too worried about replacing the plugs until you have a problem. Also, the lower port side plug on these engines is incredibly hard to get to. You probably need to remove that lower cowling, which is also difficult. So yeah, if you want to check a plug, just check one of the other ones. But I wouldn't be going and ritually changing the plugs yearly or 2 yearly or whatever. I would just wait until you had a problem, because those iridium plugs are incredibly good, incredibly long life, and if you use them, you shouldn't have a problem. The air compressor also has a little filter attached to it, and I've got one here. It's just a little, like a tiny little air filter, like you might, a small version of what you've got in the car. So I replaced that a few years ago. I don't replace it regularly, but I just check it visually once a year just to make sure it doesn't look like it's gunked up. But as you can imagine, you don't want the air compressor sucking up any dirty air or bits of impurities and putting that into the engine, possibly blocking your injectors. So yeah, for about 20 odd bucks, I think, for a little air filter, it's a good thing to change, and it's something that you can do. Just a couple of other closing comments before I start it up. One is that if there's anything that's I haven't covered here, or you still have a problem and you do need to take it to a mechanic, these engines are very complex. As I say, they've got these dual injectors that run at different pressures, and you need all the diagnostic tools, the computers and everything, if you're going to work on these motors sensibly. So don't be tempted to just take this engine to any backyard mechanic or whatever. Make sure you go to a dealer that's got significant experience with these type of engines, and that they've got all the tools necessary, because if you take it to a backyarder, they might do more damage than good. So please use a professional if you do need to take care of them. Just another tip, if you are looking to buy an engine, you haven't bought it yet, and you want to know whether it's had its regular OEM services, there is a Mercury website. If you just Google Mercury Marine Service History Inquiry, so that's Mercury Marine Service History Inquiry, and then once that website comes up, there's a dialog box for you. You just pop in the serial number, and the serial number is just on the midsection of the engine. You just pop that serial number. You don't have to register or anything. You just pop that serial number straight in, and it will tell you what services have been done on the engine, whether it was the 20-hour, 100-hour, the 200-hour, or whatever service it was, and the dates that the services were done. And so when the mechanics do those services, they actually have to enter that into the Mercury website when they do the service. So you can do that as a bit of a check. So what I'll do now, I'll just turn on the water, and I will start this baby up so you can find out what it's like to hear this, if you haven't had one of these already. Just bear with me for a second. turn the water off. So I mentioned I was going to just show you a few of the closer details on the engine before I wrap up. So here goes. Firstly, I wanted to show you the oil pump. You may not be able to see it. Now this one actually does leak a few drops of oil every time I take it out for a trip. Not much. And I did think about replacing it, but the oil pump's around $600 or $700 plus labour. You're looking at $1,000 plus for a few drops of oil, I reckon. Don't worry, just put up with it. But that's probably the only major niggle I've got on this engine. The only other one was, I mentioned it. Well, I haven't mentioned actually, but it screams a bit when you're tilting down. You can hear that. And if any of you out there know what that means, I heard it might be a bypass valve in the tilt circuit, but if anyone knows, let me know and I might see what I can do about it. But again, it's just a noise. I'm not too worried. Here is the engine mounted fuel filter. So it just basically unscrews off, and it's a bit hard to get that off with fingers. What I use is a little oil filter wrench, which I didn't show you, but I will. I'll get it out and show you. But there's a little oil filter wrench which you can use. What else did I want to show you? I think that'll about do for this video. So I want to thank you for just staying with me and listening to all my points, and I want to wish you all the best of luck with your purchase if you go and buy one of these. As I said, if you just follow some of the little things that I've told you to do, these engines can be fantastic and thoroughly don't deserve some of the bad press that they've got. So good luck, and goodbye from Tony in Sydney, Australia, and I'll see you on the water.